Hello, in this presentation we shall see how to simplify exponents containing multiple integers. Let us take some simple examples. Let us look at some simple examples. Example, let's say we have 2 to the power of 3 times 3 to the power of 2. In this case, we will try to recognize what the base terms for the first term are and what the base term and the exponential term for the second term are. For the first term, the base term is 2 and the exponential term is 3. For the second term, the base term is 3 and the exponential term is 2. In step number 2, we will recall the concept and then apply it. The concept is the number of times the base term needs to be repeated is indicated to us in the exponential term. So we will apply this concept to each one of these exponents which are given to us. So 2 to the power of 3 times 3 to the power of 2 can be expanded as 2 times 2 times 2 as far as the first exponent is concerned, and as far as the second exponent is concerned, we're going to repeat it 2 times 3 times 3. So we're going to simplify the math here. 2 times 2 is 4 times 2 times 3 times 3 is 9. So we take two numbers at a time. 4 times 2 is 8 and 8 times 9 is equal to 72. And therefore, when we have two integer exponents like this, 2 to the power of 3 times 3 to the power of 2, the answer is 72. The answer is positive 72. And this was a simple example as far as multiple integers are concerned. Let us look at a couple of more examples. And then in this case now, let us make sure that we keep a negative sign to one of the exponents, negative 2 raised to the power of 3, like that, and then 3 raised to the power of 2. We will recall the steps, we'll recall the concept, we'll write it down in steps. First step is we want to recognize the base term for the first term and the exponential term. For the first term, the base term is negative 2 because the negative sign is inside the parentheses. The negative 2 will also be raised to the power of 3. Therefore, the base term is negative 2 and the exponential term is positive 3. For the second term, the base term is 3 and the exponential term is 2. Therefore, we're going to now apply the concept. The concept is telling us that the number of times the base term needs to be repeated is indicated to us in the exponential term, and therefore we're going to use that concept for both these exponents which are given to us in this particular problem, negative 2 raised to the power of 3 times 3 raised to the power of 2. So negative 2 is going to be repeated 3 times according to the concept, and in the second part of it, the 3, which is the base term, will be repeated 2 times, 3 times 3, like that. And therefore now we're going to simplify the math. Negative times negative is a positive, 2 times 2 is a 4. We're going to take that and multiply it to negative 2, and then we have 3 times 3, which is equal to a positive 9. And then here, positive 4 times negative 2. Positive times negative is a negative. 4 times 2 is an 8. We're going to take that and multiply it to the 9 which we have. And therefore, we have negative 8 times positive 9 is equal to negative 72. Therefore, what we have here is negative 2 raised to the power of 3 times 3 raised to the power of 2 is equal to a negative 72. And this is our answer. This is where we want to leave it. This is another example of multiple integers using exponents. Let's look at another example here. And in this case, let's put the negative sign outside of the parentheses, negative of 2 raised to the power of 3. And then we have another exponent which has the base term with a negative sign raised to the power of 2. So in this situation, in these types of situations, we're going to again recognize the base terms, recognize the exponential terms, and then apply the concept. For the first term, the base term is 2, the negative is outside, it is not going to be raised to the power of 3, therefore the base term is only 2, not the negative sign. Negative sign will be part of the answer. So the exponential term here is 3, and for the second term, the base term is negative 3 because the negative sign is inside the parentheses, therefore negative 3 will be the base term, and the exponential term now will be equal to 2. Good. Now we will apply the concept. What is the concept telling us? The concept is telling us that the number of times the base term needs to be repeated is indicated to us in the exponential term. So let us write down the problem. Negative 2 raised to the power of 3 times negative 3 raised to the power of 2. For the first term, the negative sign is outside, therefore we're not going to raise the negative 2 3 times. We're going to put the negative sign outside of it and then just raise 2 to the power of 3, or repeat 2 3 times. 2 times 2 times 2, just like that. And in the second exponent, we have negative 3 as the base term, and that negative 3 will be repeated 2 times. So therefore, negative 3 times negative 3 is the way we want to write it out. And now we go to simplify the math. We go to put the negative sign outside. 2 times 2 is 4, and then times 2, and then negative 3 times negative 3 is a positive 9. So we're going to simplify this some more, and when we do that, this is going to be negative 8. 4 times 2 is 8 with a negative sign, and then we're going to multiply that by the positive 9. Therefore, we have negative 8 times positive 9 is negative 72. And the problem we had was negative 2 raised to the power of 3 times negative 3 raised to the power of 2 is going to be equal to negative 72, just like the way it is indicated here. And then this is how, no matter how the negative signs are, and if we were to be given multiple integers in this format, in exponential format, we can always be able to apply the concepts, break it down into steps of this nature, and then be able to simplify the math and get an answer of this kind. So in my next presentation, we shall see how to simplify exponents containing fractions.